A fluid of specific weight of 58 pounds per cubic foot flows by gravity through a 1-foot tank and then a 1-foot capillary tube to atmospheric pressure at a rate of 0.15 cubic feet per hour. Calculate the friction loss, assume laminar flow. Okay, so we're going to take a look at this, and we're going to use that modified Bernoulli's that we just looked at, so let's make some assumptions. Let's move it back to where we should be. And so we're going to assume laminar flow. We're going to assume it because the problem told us to assume it, and I'm fine with that. We're going to assume that it's a steady flow. There's nothing about change of time in here. We're going to assume, what else are we going to assume? An incompressible flow. So we can use our equation. Incompressible. And I'll also write density equals constant, same thing. And there we go. So if we take a look at it, our modified Bernoulli's, what is that going to tell us? We've got pressure over specific weight plus alpha V1 squared over 2G plus Z1. And that's all going to equal all this stuff at 0.2. And then we have whatever head loss that we have through the pipe. So let's start taking a look before we even go anywhere. Let us look at what we can knock out of the equation, make it a little bit simpler for us to solve. We're just going to set Z2 equal to 0. V1, surface of a large tank. So we're just going to say V1 is equal to 0. And since we're taking the surface of the tank, 1, so here's our streamline from 1 to 2. We're going from the surface of the tank, which is at pressure, atmospheric pressure. The exit of the tank's at atmospheric pressure. So those will fall away because P1 equals P2. And so, wrong button. Sorry about that. What we're left with is an equation that we've got. Z1 is equal to alpha V2 squared over 2G plus HF. And that's it. We just have to solve that. And actually, let's rearrange that for HF, actually. So HF is going to be equal to Z1 minus alpha V2 squared over 2G. Now, we know what Z1 is. Z1's 2 feet. What we're going to need, though, is we're going to need to know what V2 is. So to calculate out V2, I know that I have a flow rate. The flow rate is going to have to be equal to Q2, which is, where was it here? 0.15 cubic feet per hour. And that's going to equal V2 times A2. So we know A2. We know Q, so we can figure out V. First, we need to convert Q over 1.5 cubic feet per hour. The cubic feet is fine. The per hour is not. And so what I'm going to do is I'm going to multiply that by 1 hour. 1 hour is 60 minutes, and in each minute 60 seconds, so that's 3,600 seconds. And that will end up giving us cubic feet per second. So we have a very small number here. So, sorry, I just need to convert that over. So it's 4.16 times 10 to the negative 5 cubic feet per second. So now we're going to take that, and I want to divide that by my area. So we will multiply that by 1 over the area to get our velocity. And so the area is, we have a 0.004 feet diameter, so pi over 4 times 0.004 feet squared. And that will give us 3.32 feet per second. So now with my velocity, I have everything I need to solve the equation. So now let's sub all of the numbers back into our equation here that we're trying to solve, which is our HF is Z minus alpha V squared over 2G. So here we go. HF is equal to, I'll just rewrite the equation here so we've got it. Z1 minus alpha v2 squared over 2g. So z1 is 2 feet above where we're at, so 2 feet minus alpha, laminar flow, so that's a 2. And velocity, 3.32 feet per second, squared. Divide that by twice gravity, so 2 times 32.2 feet per second, squared. Oh, I'm sorry. Yeah, feet per second squared. So if I take a look at things, units on the top, I'm going to have feet squared, second squared. Units on the bottom, I'm going to have feet per second squared. That's going to leave me with feet. So this term is in feet, this one's in feet, so I can subtract them, so that works out well to my, that's what I need it to do. And so 2 minus all of this, if I calculate that out, I'm going to calculate out that I have 1.66 feet of head loss due to friction in the system. Now, a couple things to note. Specific weight of the fluid really didn't come into play. It's information that was not really needed for this problem.